In this video we'll be testing the accumulator register for the transistor processor. This is an easy board to test. It's essentially just 3 registers. You have the accumulator register itself, and then the register B and the output register. There are actually different types of register. The first one, the accumulator, is a 2-stage latch, and B and output are transparent latches. The reason we can use transparent latches for the B and the output register is because their outputs never affect their inputs. But because the output of the accumulator could, in theory, affect its input, you don't want a kind of a circular race condition going on while you're trying to update it. So it is a 2-stage latch. But because we don't have the output connected through to the input, we don't need to clock it using both clocks. We can get away just updating it with a single clock. So we'll do that to simplify testing. If I now turn the power on, notice that we get a random indication from the LEDs, and that's because, of course, the clock board's not plugged in, so there is no clear signal being asserted when the power comes up. So we'll start by manually clearing the registers. So they're now all clear. And the testing is just simply a case of latching different values from the data bus into each register. So I have the various latch control lines connected. So we have LA for the accumulator, LB for register B, and LO for the output register. I also have the enable accumulator line, the EA line, tied to plus 5 volts, and that's to make sure that we don't have a kind of a circular update system going on where the output of that register is connected to the data bus while we're trying to update it. That would cause some confusion. Okay, so what I'll do now is set a value on the data bus. So I'll just take it to 0. So I'll set all the data bus lines to 0. Okay, they're now all on 0. We'll start off with the accumulator, and I'll strobe the clock, and of course nothing happens because we already have a value of 0 in there. So I'll now, but it's important it doesn't change. If it does change, and obviously we've got a tied bit somewhere. So now set bit 0, strobe the clock line, and you'll see that the register has updated. I'll select the LB, the register B line, and now register B should be updated with the same value, which it is. And then finally the output register, we'll strobe the clock line again, and you'll see that it is also updated. And that is all you do. You just go through and put different values in. I'll put a random value in just to show that all the bits are updated at the same time. Okay, and then we'll go from the left again. So accumulator updated fine. Register B again works fine. And then finally the output register works fine. And then just check to make sure you can clear them all, which we can. And that's it. You just go through, put various different values to exercise each of the bit in each register. Make sure that there are no stuck bits and that all the bits toggle as they should, and that the data is retained after the control line goes back to high. That's it. This board's now ready to go into the processor.